Okay, this is the P2 paper from January 2022. It's question 4, and as we can see quite clearly, it's logarithms. Using the laws of logarithms, solve, and then that equation there. Let's copy the equation down. So we've got log to the base 3 of 32 minus 12x is equal to 2 log to the base 3 of 1 minus x plus 3. A number of different ways you can approach this if you'd wanted to. I'm not going to do this, but you could turn that 3 into a log to the base 3 valuation, and then you've got all log to the base 3s and try and tidy those up. I'm going to do something similar, but not exactly the same. What I'm going to do is to take that term over to the other side, and then because I've got two statements with log to the base 3, I'm just going to tidy them up using all the various different log rules. So let's get started with that. We've got, this thing's not changing, log 3, 32 minus 12x, minus 2 log 3, 1 minus x is equal to 3. And now here's my first problem. I want to be able to combine these two logarithms, but I can't if I've got that 2 there. But not only is it a problem, it's also an opportunity. One of my log rules states that if I've got n log a to any base, it doesn't matter what the base is, what we can do is we can take the power up there, so we can get is log a to the n. So that's what I'm going to do with this term first of all, so that the 2 moves up into the powers. So let's just do that. Everything else is staying the same. Log 3, 32 minus 12x minus log 3, 1 minus x squared is equal to 3. And the whole idea of doing that was to end up now with just log minus log. And if I've got log minus log, another one of my log rules says if I've got log a minus log b, that's the same as log a over b. So I'm going to use that one now. All the way through this, my aim is to try and get just a single log statement, and I'm going to get there with this next bit here. So log 3, 32 minus 12x over 1 minus x all squared. I've now taken what I had at the start and turned it into a single log equal something. Why do I want to do that? Because there's another log rule, isn't there, which says log to the base ab equals c. If I start off with that statement, I can turn it into a power statement. The power statement, when I'm trying to work this out as a quick memory thing for myself, one of the things I say, or that I understand it, is that a logarithm is actually a power. So that bit must be a power. And I also know that when I do these, the base of my logarithm becomes the base of my power statement. So putting those two things together, that's the base. The logarithm is a power. I end up with a to the c equals b as my statement. These two things are interchangeable. So you can say the log statement to the power or the power statement to the log. Remember it whichever way you want, but you need to make sure you do know that one. And I'm now going to apply that to the equation that we've got above there. So I said that 32 minus 12x all over 1 minus x all squared is equal to this, the base, to the power of this. Well, actually it doesn't make any difference with this one because they're both 3's, but we still need to understand what we're doing, don't we? So I get that as my equation. Should be easy from here. That looks just like something that needs tidying up. Just take your time, they don't do anything silly. So 32 minus 12x all over 1 minus x squared equals 27. Just do the cubed. And now this thing can go up there and become times, can't it? Just normal algebra stuff, 27. So we get 32 minus 12x equals 27, lots of that. So at this stage, guys, I'm not going to spend any time talking to you about 1 minus x squared. So 1 minus x times 1 minus x, you can just work that out yourselves, I'm going to have that already done. 1 minus 2x plus x squared. So 32 minus 12x equals 27 minus 54x plus 27x squared. And now what I'm trying to do with this is to turn it into our normal quadratic format, which is ax squared bx and c equals 0. Okay, so I've just taken it all over to the right hand side, tidied up the minus 54 plus 12, tidied up the 27 minus whatever. Now when I get to this stage, they do a couple of tricks here. Sometimes everything will divide by 5 or by 3 or by 6 or something like that, or it can just factorize out. So I'm looking to see if I can factorize it. Now, you can always stick it into the formula if you want to. I'd suggest you don't. I'd suggest you try and get really good at your quadratic factorizing. It's an IGCSE skill, isn't it? But either way, if you manage to do it, it factorizes down to that. So that's 9x plus 1 equals 0, or 3x minus 5 equals 0, which gives us our final answers of x equals minus 1 over 9, or x equals, what's that, 5 over 3. So those are my two answers. Or are they? We just need to be a little bit careful about this. Go back and check. So the first thing I check for are decimal places and significant figures, but also I want you to have in mind, if we've got a log statement, remember, you can't do log of a negative, okay? You can't do the log of a negative. It's like divided by 0 or the square root of a negative. Those things don't exist. So actually, this is a really sneaky little bit here. If we actually used that one, 5 over 3, then up in here, we'd have log 1 minus 5 over 3. We'd be doing the log of a negative, and that doesn't exist. So that solution is actually not a solution. So we have to say not a valid solution. So our actual answer is just x equals minus 1 over 9. How many marks is this one worth? This is worth 5 marks. You don't want to lose that mark, or at least be looking out for it. Just a sneaky little one at the end of that question. Okay, hopefully that makes sense.